everyone, I hope that you can hear me this time, and welcome to the second live sessions of Flutter Portugal Live. Last week we had two sessions, one by me and then another by João Soares, in which we have gone through the steps of how to create a complex UI and animations in Flutter. This week we'll have Argel and Rafael, which will focus on asynchronous programming in Flutter and Firebase in Flutter. As with last week, each talk will be 45 minutes and then 50 minutes of QA. So please join the chat that's in this direction. Yeah, join the chat here or tweet at us, or even in the YouTube chat, post your questions, and then we'll have some Q&A with our speakers. The first talk, Asynchronous Programming with Argel, will be just in a minute.
Let's do this. Hello everyone. Today I'm going to be working about asynchronous with Flutter. But first of all, I'm going to say thank you to the Flutter Portugal community and every single one of you are here right now. This is a pretty good acknowledge to achieve, to get in there and know how it's worked properly. But first of all, this is me. My name is Argel Bejarano. I am from Mexico, from the north of Mexico. I'm a software engineer. I'm a Flutter developer for more than 2 years, almost 3 years now. And the founder of the Flutter and Dart Spanish community. We have around 15,000 people in there. We have this community in Twitter and we have a Telegram group with, I don't know, maybe 3,000 people in there. So it's a madhouse in there. So if you want to go in, so you are welcome. We speak Spanish, but you know we can try to manage in there. And in a GTG organizer in my city also. So let's go to the topic. The scope for this talk is going to be about completely futures, right? So let's talk about the theory. What's an isolate? What's an evolve? And what's a future? We're going to take these definitions to a little bit deep in understanding, so we can be better when we are working with this. So we're going to look how the future works. We want to look at what kind of future constructor does it have. It's not only sync away, that then they have a lot of different constructors that you can use to help you to mock your information. We're going to look at this in live coding, a little bit of this with the same app that we were working last week. And also it's pretty important to know how to handle the features. We have the then, we have the async await. We're going to go and look at the difference in between them and how to use it, and maybe you can get something from this talk and it just improve your code. So let's talk first. What's a feature? I'm gonna read this because it's the exact definition that is in the Flutter documentation. You always need to know how is this definition in Flutter documentation. It says a feature is used to represent a potential value or error that will be available at some time in the future. I actually feel like they don't feel comfortable with this definition because it's kind of recursive. So let's try to move. Are you listening to me? Hello.
It should be all good.
Should be all good. Okay. Sorry, I was.
Yes.
Yeah. Okay? I was saying. Let's see a basic sample and move in deep in this topic. So let's think about the future. If it's a little gift box, okay? So when we ask for the delivering a future response, we can have two states. The first one in there, it could be, is everything goes well, you can have your little dash saying it's okay. But if you go in the other side, you could have a message and it can say, no, we have an error. So this is the only way that the feature works. It sends you an error or a value. So that's the definition that we read before, but I feel like this analogy is an improvement. So let's go as a good developer and Stack Overflow this and get to the code, because this is what we do. So let's go in topic. as synchronous as possible thanks to the isolates in Darts. So the isolates run in a single thread, they have their own memory, and they run an even loop. Okay, this is basics that we need to know. So, but a question that I always had is, do we need to we can only run one of these? And no, you can run more of these, but it's not good to be creating new ones and new ones and new ones. So you can create if you have a big job to do, you can move it to an isolate and make the work in there to process it and exchange data in there. But that's it. It's not a good idea creating for every single one of this. So let's keep it in there. You can create more, but it's not a good practice to do it. So the Dart application, even they are amazing in everything, they only run 2 steps to initialize this. The first is to have 2 keywords. One is called microtask and the other one is called events. We're going to take in deep in this a little bit in the future. So let's after that, they execute a main function and create an even loop. And this even loop is all our code moving and is controlled and whatever the magic that we can create with the Flutter app, with the Dart code, it's running in this main, as we all knew. So I'm waiting for this slide, but you may think, well, what happens when you don't have anything in there? If the user just get your phone and is looking at them and is doing nothing, just like that. So we may think, well, so what's doing the even loop? What's doing the isolate? Is like waiting for something, just laying it there, or what's it doing? So what it actually does is being thinking about, okay, I have enough time, so I'm gonna run the garbage collector. I add that all the time that I need, because this thread, because it's only one thread, is never locked. It's never waiting for something else. So it can get everything, and when the user decides to tap on something, move to the screen, or handle some events in there, the garbage collector goes, and then you can start processing your code. That's what the even loop with the isolate is doing when you are doing nothing. They are just waiting for something or running some underneath functions so you can improve the experience and clean memory and all the magic in the bottom. So just to finalize this, the process is on this, and the team Flutter saying like that. The future it's going to be uncompleted at the beginning because they are asking for something, and it's going to be completed with value or with error. Remember those little dashes, the one is okay and the other one that was crying. So this is the basic usage for the future. We don't need more information, but just for fun, just going to go a little bit further, okay? So this may be going to sound familiar on this. It's a network communication and shared preferences. Both of these were used to be using because we always need to have information for HTTP calls, some GET in there, retrieving information, or some shared preferences because, I don't know, maybe we want to save, I don't know, the token of the user or some specific values in there. I don't know, it could be anything. But they are always a feature. But they are default ones. You can use some default feature constructors so you can test some behaviors. Maybe because you're in a startup sometimes is like the development is going to be in the same time that the UI from the backend. So it can get confused. So I can work because I don't have my backend done. So we're going to stop doing that. We're going to say, okay, which information you're going to send me? This one. Okay, I'm going to work with this. I'm going to create the user interface. I'm going to create the code. I'm going to create my methods. And when you are ready, as you're going to use your endpoint and use it. That's it. So back to the future, right? We have this feature is the basic, is the default constructor for that class is just a return number 42. I always think that number, I know maybe I've seen so much in a lot of places that I remember 42. And someone says, oh, this could be smaller. Yes, it could be smaller. You can use a fat arrow in there, but it's the same code actually. And then you can also use this future.value, and it's going to be sending this value in a specific value. You can use it for send anything you want. That inside of that is a dynamic value. So you can send an object, you can send a string, you can send an int, you can send whatever you want in it. In your user interface, you can send it with this. So we have also this one is you have been familiar with this, is creating delays. What is important to use these delays? Because we always need to try also not only the exact moment and we have the information to put on the screen. We also want to use this and put it in a little loading at the beginning and maybe send an error. Right now we're not sending an error in there, but if we can send an error, we can mock all these states of our asynchronous calls and have a good experience behavior. Even if we don't have a backend to communicate, we can force these kind of errors. So if you are reading this and you say, oh yeah, the result, the print gonna be printing 5, what's my future 42? I'm sorry to say you that it's not true. It's not true because we run this, we're gonna be seeing this one. What's my future instance of future end? The future node is just an instance of the future. It's not the actual future. We are not doing that then. We are doing an async await call. This one is a fix. It's just future.then. After we have this, we put a future.then and we print it. Because the code in the futures is going to be executing from the top to the bottom. It's going to start, make the delay, waiting for the value, and print. So this is going to be printing what's my future, and in the next line is going to be printing 42. That's the way it works, because this is synchronous and the future became in converts a better conversion in there from asynchronous work. So, but it's one more, and one interested constructor there is called microtask. This is work a little bit different. Remember in the past, when we travel to the past, we have been using a microtask keyword. So this one have different way to use it. So let's go back to the old times, and we're gonna be using this diagram. So we have the start. When we start, we create these two queues. The one that is used for events and the one that is used for microtask. If we run this, it's gonna be asking first, do you have a microtask that I have to be running? And you said yes, it's gonna be working in that and execute it. If you say no, you're gonna be keep moving to the next event, to the event queue and make the same question. So it's gonna be looking like that. I know it's not that easy to understand, so let's move to a little bit, as I told you, Stack Overflow this and move to this example. So we have a main, we have a print that says begin, we have a microtask, we have a regular feature that we already see, it was a print, and that then we don't print, and blah blah blah, more in there. We have a second microtask, we have a second feature, we have a third microtask, and we have a print at the end. So following the rules that we saw in the back diagram, in this diagram, this should be running how? Begin, end, because these one are running synchronously, and then I'm going to be waiting for all the events in the queues. So how does it work? Like this. It's going to be begin and end main. Then it's going to be running the microtask, the first microtask, then the second microtask, and then the third microtask. After they finish, it's going to be asking, so I have more microtask, and just find out that it doesn't have any more microtask because there are only 3. And after that, you're going to start to working with the events in the future. The future is an event, so it's going to be in the event queue. You're going to start executing as a first feature, then the first then the second then. But in there, you're going to find a microtask. So what is going to be happening here is going to go back and ask, oh, you have a microtask in here? He said, yes, I have one. So it's going to be executed first, and then it's going to be to the second feature and going to finish the other feature that it has in here. Oh, sorry. You're going to finalize those features. So why is this important? Because maybe you have something that has to be executed in the future, but you need it before some event. It's this little place in between that you need to use this. So it happens. It had happened to me once, twice. So I had to read a lot of them because it's not a lot of information about this. So, and I find out that it's pretty useful. So it's if we can have a definition for this, the microtask is going to be something that needs to be executed on the future, but it's going to be executed before the event. So that's why it executes first, and then they execute the future. First microtask and then futures. So this is, I know this is not, maybe it's so easy to understand at the beginning, or maybe it is, and if it is, it's amazing, because it's something that is, it's good to know. So let's move and talk about then and see what is the main difference of them. So let's see then. We have a future. Remember, we have an instance of the future, so let's put it in the var, and then we use future.then, and we print the value, and then we add something and then return and send it to the second value, to the second then, and then we try to catch an error, but no error happens in there, so keep moving, and then we throw an error, and then we try to add some value and send again a new message, and a printing in console new message. And we use this when complete. I have been approached a lot of times in my community. They asking me about how they can force a feature to always execute something, because if something happens, it goes to the catch error, and maybe you have something after that, maybe a loading value in there, maybe a true value or something in your state that says you have to, maybe you have just a change notifier and says notify that the value is finished, and you have to put it in your then and put in your catch error, and you have been duplicated code in there. Maybe you can move it and put it in when complete. So when the feature is complete, it's going to be always printing here final, or it's going to be always executing something. Even if as an error, if the feature returns an error or a value, it doesn't matter. The when complete, it's always be executing something. So, but I don't. You can use this. It's completely good code, but it feels like it's crowded. At least for me, I feel it kind of crowded. So I like this. It's better, more readable. So remember, your main can be async. It's not any issue in there. You can use async in the main. So you have a try catch finally block. That easy. Try catch is not only for this. It's not only for future. You can use it with whatever kind of code you can to catch an error in there. But yeah, it's that easy. You have the future. You print it. You add something, because you don't need any future again, because your future was a 42, and then you can move to this, and then when the error happens in there, it prints an error, and then finally it's get the value and print finally. But it's the same code. You can see it's the same code, but it's more readable. So this is after you. Maybe you can say, oh, I just have one then, I don't want to make async my call, I just want to use it like this. It's completely good. But you need to know all the steps that it happens in there. So let's code a little bit. I'm going to move to the code that we have in here. So let's. This is the app that we were working last week, and we are seeing this is the same code. I haven't moved anything. It's exactly the same code. So let's make a move. Let's look this. I don't have to move anything here. I see here one little, could say the little confusion, because we have been using a duration in here, but you can create a duration. It's going to be a type min duration, because you can send a duration from the backend. So let's make a little change and fix it, because a duration is a type we already been using in here. With microseconds, seconds, milliseconds, and whatever, we are using duration for a lot of animation stuff, so we know what it is. So let's make a little change and set everything as it should be. Just with this. Let's put it like an int, because there are minutes. Minutes are gonna be like exactly like that. So we're gonna find we have some issues in here. So let's fix that. We're going to move in here. And we're going to use like this. That should be it for that screen. And we have in here some differences. It's going to take a little bit to fix this, but it's because from our backend it's going to be sending, like, maybe you have to send minutes and hours, so you have to create a class saying 1 hour and 12 minutes or something like that. So right now it's going to send an int. This is a good practice. This is I don't know, maybe it's a big number, so I'm going to use this big number. So this is going to be, I don't know, 500. It's a bigger, so I'm going to put 10 more minutes. It's going to be 150, and it's going to be 160, and it's going to be 30 minutes. Because if we look at our code in there, they are just using minutes. Actually, it doesn't be needed something in there like doing this conversion. This is an error in here. We're just going to fix it easy quickly, just for not seeing the red line of that. So let's just move this. So if we execute it again, this is going to be working as usual. It doesn't have anything else. I'm going to move this aside because we don't need it in there. So remember, this is live, and we are streaming, and we are executing simulator and IDE. So it's going to be a little bit slow, but it's kind of the charm of being in the live coding. So everything's working. We are seeing the same values and stuff, so it's okay. Let's make something. First of all, we're gonna need a way to work with this. It is as these values. So when you see this, well, it's a pretty good class, but you always have been seeing that you have this from JSON to JSON, and you have to create it, and don't know how to, or it's taking you too long. So I just create the JSON for this. They're gonna be with a string, with an int, a string, a boolean. So I just use this this website in here. In this website, create the what you need. I mean, it's for the beginning. Maybe you can use some JSON annotation. You can want to run just build runner with some awesome like JSON retrofit and other plugins amazing that are out there. So right now we're just going to use the basic. I'm going to comment out this. I don't like to delete code, but maybe later it's not going to be working. So let's put it like this. Okay, so as we see, we can run this code. It's because it's something same code, and we have this repository. Oh yeah, I'm gonna do a fix. I don't like to use it like that, but it's gonna be harder to move it to the other way. Right now, it said that I need to put the names of every single one of the, because it were named. So I'm gonna to remove it. It's gonna be easier like this. It's not part of the synchronous work, but it's important to know that one good way to work with our code, and what is not a good idea to name classes after something that it actually exists or exists already. So what is happening here is that we actually need to copy this and put it in here. That's it, because it says, oh, you have saying 9 and we are sending it 8, so I can't work like this. So that's it. We just fixed some little configuration that wasn't working how it should. Gonna be sending this over, and we have our class. We just take it from here, put it the JSON that our backend send us. That's okay. This is gonna be the backend, the basic JSON that we're gonna be sending. It's gonna be in a list because it's a list of recipes, and that's it. We have our model more complete and a better way to use it. So let's move to, this is already working, but we have something in the repository. We just calling for the recipes. We're actually doing a future call. So let's copy these two, and let's mock if there were sending some future, and this is going to be a future. So what it needs here to be done, it needs to be set as a future. I forgot to do this. There we have, and also in here we need to add it like this. But right now we are not sending a future. So do you remember we were talking about a constructor that it says, hey, you can use a value in there. So let's do that. Let's copy this. It's going to be a future that delay. We can use value, but it's not going to be waiting. So we're not going to be able to show something in the screen while the user is waiting for our call. So let's send. It's going to be a duration. Remember, we removed this duration because it was already in there, and it's not good to have it in there. And let's just set return. Well, actually, I think we can use this. And this is going to be our future. So let's get all of these values and put it in here. And now we are having fake data, a mock future, so we can use it in our user interface. Because what was going to be happening here? Here you can you can do the whole call, your .then, or use your async await in there. The only thing that needs to be sure is that you have to return a list of recipes. It's gonna be with capital R, and this is the only thing you have to be sure that you are sending back, a list of recipes. Okay, maybe let's try it. Let's use async, and let's use this and this list. It's gonna be await, and let's get this webcam, like so, and here we're gonna be returning that list. And right now we are doing exactly the same, but right this time we are actually doing an asynchronous call. So what is going to be changing in here? First of all, you need to be catching some error, because maybe they're going to be sending a 400 status code, so for 404, and that's not going to be working for us, so we had to throw an error, or we had to be doing some loading stuff and a lot of things. So you can add here a try catch, and finally if you need it and everything we already saw. But just for this, in this case, we're going to be using like this. I'm going to left this just for not being boring you seeing me write code. So let's move to the home page. So right now everything is going to be working. I actually don't change anything from the user interface. You have to remember the user interface is the last thing you want to be moving. You have to be sure you have a good classes, a good model, a good foundation with the abstract, because you're going to be testing it and everything else, and at the end you have to be working with your user interface. But let's look at this, and we're going to create in the top of this is going to be the recipe grid, this one at the top. I'm going to create a feature builder. A feature builder can have a few values. You have initial data you can set, so you know it's going to be a list, so you find a list. But it's important to say it's going to be a list, and it's going to be a list of recipes, because that way you can know and use the exact type when you're going to type in the values. So let's move in here, and says, okay, where's my future? What is going to be my future? So let's get the recipes. This is going to be the recipes store, but we're going to be getting, it's going to be widget that recipe code, and it's going to be get future. No, this is the other word, is recipe get special. Oh yeah, that was the one. And then we're going to be saying in the builder you can send those values, two values. The first one is going to be context, but we are not going to be using context. In the other, we're going to be snapshot, the one that actually get the values in there. So let's return. We're going to be returning this one. Okay, let's make this like this, and let's put it in here. I'm gonna comment it out this because I don't want to be duplicated information in there, and do a little bit of reformatting. Let's see like this. We're sending this information. We have everything like that. It's going to be the same. Okay. So what are you going to be using here? We are not going to be using the call because we actually need to wait, and this recipe grid is not working with the async call. It's actually the snapshot.data, the one that we're going to be using. That one is the same. It's going to retrieving that information from that list, that recipe, and then it's going to be mapping that. We need to do something first because remember it's going to take 2 seconds. So we're going to say if snapshot.data that is empty, we're going to be returning a circular progress indicator, circular progress indicator. Okay, let's see what has happened when I do this. So it's going to be showing it wasn't centered, so let's enter this. Just going to be easier like that to see. You're going to be in the middle. You're going to see that. Let's go to move to the beginning so you can move the whole. When you're going to went in, this feature builder is going to taking care about this call. And you're going to be seeing, okay, I'm going to be loading. After 2 seconds, we're going to be sending you the information. Also, you can, from this snapshot, it has a lot of things, a lot of fun stuff. You can use a snapshot.error. So if the snapshot has an error, it can have a connection state like a waiting or loading. You can manage all these states in this widget. So it's one of the widgets. You can use another ones. You can use it with your state. They work with the feature, using consumer and manage in a different way. But this is the easiest, the first way you need to manage, and you to be sure you're looking to them and know how to make it work. So let's take all of this and let's move to this one, because we have another one in here, the feature builder, and this is going to be using the list recipe, and let's add this in here. And right now we need to call this because we're going to show the same thing. Even it's different. This is just a loading, so it's not a big deal if it's showing that, but the call is going to be different. We're going to be using recommendations. We're going to send back these recommendations, and so return recommendations. Get to put a little comma in there just for formatting. It's a good practice to format your code. It's more readable. But in here we are not going to be using the same. It's going to be using snapshot that data, but also the call is going to be different because here we're going to be having the recommendation only. The other one that had the same logic. So let's go to the initial behavior, to the login screen, and one thing to the same. We just change a little bit of the model because it was a little confusion using this duration like a class, because Dart already have a duration in there. And we can use a start. We're going to be loading. Oh yeah, I left this. This one shouldn't be in there because it's duplicating information, and that's how you could be working. If you said, well, but I would like to not seeing these different sizes and stuff, so you can also, I think it should be good. You can use expand it in here, and we to move to the flex and say there's maybe 4% of that, and yeah, it should be working. So let's see what it does. And yeah, we're seeing this, but we don't have because the expanded is not getting another state. So it was something that was not needed, so it doesn't matter. And let's see what we actually changed. We just actually changed. If you see there, we only were loading the one that it has in here, because this one was already loaded, so it didn't make the call in our hot reload. So it's good to have the kind of behavior from the beginning. If you look at this, we're gonna keep having the same behavior from the next screen, because we don't change anything for the other screen. We just change the way we call the main recipe grid, and all of the other stuff, because you have a navigation, you have a recipe, it's in this item. I don't need to go there and change anything else. So that's like a way we can work with our repositories, mock the repositories, and being more able to manage all the usage. Even we don't have when we don't have these call from whatever backend we're using. It actually is agnostic for us. We don't need to know the language or whatever it is. We just need an endpoint, or maybe how we're going to be using in the next talk with Rafael, the Firebase. So it's going to be the same. You can just feature with Firestore, and that's going to be it. You get that instance and work with feature and good with this, and that's going to be it. So that's going to be it's going to be it for me. I'm just going to finish it up. Going to get my information in my email, my GitHub account, and my Twitter, and I have a YouTube channel, but it's in Spanish, but we have some good things in there. It's a channel with Diego Velázquez, a GDE from Peru. So that's it for me. Again, to get back. So give me a second, because I'm not so much proficient in this. Let me wait. I see I have questions. Romeo Vietol. I'm building a quiz type app for ear training. I'm trying to play a quiz exercise on loop, playing OGG files. It requires options selection that should trigger the next question on the result page. On stop, is the use of the feature mandatory in this case? Yes, because I think all the libraries, all these plugins use features like the one for video. It works with features, so you can create a controller that's going to be sending you a feature because it's going to need to be buffering some information to send you. So if future is a must in here, so you can load at least the information, and also you can you can read about the function that is called completer. So this is kind of function that helps you when you have something running and you want to decide when to end a feature. You just said to this, okay, this is going to be using this completer, and when you says, okay, this completer is complete, you can trigger something else. So take a look about this completer function and functionality, and to make it is unstop, full move to next, navigate. You can decide when to move from the future to the other one. I think you have another questions, right, Gonzalo? It was the first
Yes,
one.
we have more questions. I don't know if you're hearing me or not.
Yes,
The
I hear
first
you.
question is, do you prefer to use try-catch finally with features, or do you prefer to use the future catch error and then?
I must say that I have been using both. Well, it depends a lot of the usage, because if it's a single dot then, I can use dot then, so I don't have to make the whole asynchronous, async, await, and the whole different try catch stuff, because it's gonna be a simple one dot then. If you have to be using dot then and inside that dot then another one and then move so much code, it can get, as I tell you, is kind of crowded in there. So I prefer, depending of the situation, I use that then. If it's an easy one, just a one call, retrieve information at get user ID, something like that. It's easier. You just make the call and send the information. But if you have to work with this information and move it to this information and manage this information, I feel it's more comfortable to read this structure in a try-catch block instead of the dot then. So I use both, but depending on the situation that I'm in.
Awesome. Is there any difference between asynchronous testing and synchronous testing?
Well, when you're going to be using asynchronous testing, you have to be use these. It's important to always have contracts for these callings, because you have to be mocking this abstract classes. You have to be using Mockito, and these help you using this like when this is going to be calling, then answer or then result, and all this verifying that this code was actually did by the engine and stuff. So there's a little differences. It's not too much different, but it's actually important to mock your data, to mock your interfaces. Well, in this case, it's not interfaces, but gonna say it's an abstract class, because Dart, remember, we don't have interfaces in here. But yes, it's a a little bit different, but it's not that kind of hard also. So the answer is going to be yes, because you need to add some mocking for the repository, for these classes, and using Mockito as an extra plugin to help you to do all of this. So that's going to be important to work that.
Okay, my last question is the following. In the talk, you basically talked about how we can mock data from the backend. Do you have nightmares with that when you start creating apps and you don't have any data from the backend that you decided to do a talk about it?
Yeah, actually, what is happening is, I came from backend field, but right now I was working as a front end with Flutter and doing Dart, and sometimes I have to create my whole backend just for testing apps and doing my own and I've been able to learn. And so I was thinking, I'm sure it was backend because we have a joke when I was working before. And sometimes I thought, oh yeah, I was working with this and I dream how to fix it. I think every single one of us as developers had this moment when you're dreaming and just, oh, I know how to fix this bug. So one of the big issues that I tried to solve in this
That's awesome. I don't know if you're hearing me correctly right now, Argel.
Yes. Yes, I'm hearing you.
Okay, I don't know. I think there aren't any more questions right now. In that case, we'll go for a 15 minutes break and we'll come back with Rafael Nunes with Firebase in Flutter. Thank you.
Okay, that should be good now. Allowing it some time. I had my mic off, I believe. All good. Okay, so starting over. Let me just put a timer. My name is Rafael Nunes, and I'll be talking to you about powering your Flutter app with Firebase. So keep in mind that everything that you see today, you'll have available on my GitHub. I will put it live on the repo over the weekend, and you'll have it even truncated between branches, so you can see the different iterations of what we do during today's live coding session. So let's go into what is Firebase. So how does it actually power apps, and more importantly, is it free? So the short answer is yes, it is free. To some degree, obviously. It has a free tier, and then it has a pay-as-you-go tier. I would say the free tier is pretty generous, so you'll be fine experimenting quite a lot with your apps before you even run the danger of having any costs. And now actually explaining what Firebase is. Firebase is a suite from Google that has a connected set of tools that are designed to help you succeed at developing your apps. It basically allows you to build your architecture in their serverless fashion while providing you with multiple servers. But the really good part about it is that Google takes care of all the heavy lifting. It does all of the maintenance, all of the scaling, both up and down, and this saves you a significant amount of time, especially because they already have a lot of components already ready to go that previously you would have to build yourself. So here's a set of some of the things that Firebase, or most of the things that Firebase provides. We have stuff ranging from authentication, which we're actually going to talk about today. Then we also have analytics, database. We even have 2 offerings for databases. Functions, these are very similar to the Amazon Lambda functions. So basically, it's code that gets triggered in the cloud in order to run some tasks, and we'll also be talking about this today at the end. And remote config, this, for example, allows you to run some set some configurations for your app in the cloud, and then you can update your clients on the fly without actually updating them through the store. So it increases conversion for certain features as you go. And finally, we also have storage, which allows you to store your files, in sort of folder fashion, very similar to Amazon's Amazon's buckets. So this one also allows you to upload, download, and it allows you to even protect your data through certain rules. Oh, and also distribution. So distribution is actually one of my favorites. It's very similar to how TestFlight on iOS works. So basically, you just upload your app APK or bundle from your iOS app or Android app. You upload it, and it immediately distributes it directly to your phones. Like you can be your team, your testers, and it's made so in a very easy fashion that then is easily versionable, and they can even test different versions, and it reports back even. So it's very good. Normally you'd have to upload it to both the iOS platform and the Android platform, again, if you have an iOS and Android app, and it would have to go through like a beta rollout or something. So it would be a bit more complicated. So I like this one a lot. So to start today, we'll go for authentication. And so as with most apps, we usually want to know what our users who our users are in order to provide them with the best experience. So authentication provides us with the security and logic to manage user logins and signups very quickly. This also comes already equipped with the typical social features that you come to expect. So it's pretty awesome in that way. So it's pretty easy to set up a Google, Facebook, or sign in with Twitter, etc. And also it comes in with pre logic for recovering passwords and email confirmations, whitelisting users, blacklisting users, all that kind of stuff. So now I want to show you how to develop this aspect of authentication really easily with Flutter and Firebase. But I just want to start out by saying that you do have to just do a quick setup that for the purposes of this presentation I've already done. Let me just quickly show you what that is. So essentially this is the usual Firebase dashboard that you have. Here you go to your authentication page, and since we're going to be doing Google today, we need to enable Google. Okay, that's the first step. And then you actually need to go to your settings, and in your settings, that's where this comes in. So we're going to actually create this JSON that we need. And to do that, for example, today I'm going to experiment with Android. So I've set up an Android app by clicking Add App, and then just doing the necessary steps, which is putting in your package name, signing, providing your hash key from your Mac or Windows PC, and then just get the JSON, put it where you need in the Android tree, and finally just add a few lines to your build-up Gradles on your Android tree. So now we can go into code. All right. Okay, so for the purposes of today, we have an app that is based on what was done actually last week, but as you saw, the previous talk also played around with this app. So this app, simple, but I've made some small changes. So right now, we have these recipes. They're already hard-coded in the app. They're locally loaded, and they go into a details page. We have this that allows you to favorite. None of this is real functionality, it's just animated. So what I have added is a logout button and a login button. But keep in mind, these are completely useless right now. The only thing they do is they navigate between screens. So the login button goes into this intro page, and the logout button goes into the login page. That's it. So there's no actual functionality going on yet. This is just pure routing. So let's actually implement some logic to it. So the first thing we need to do is we need to fetch two libraries for Flutter. So these two will be, sorry, give me a second. So this will be Firebase Auth. So Firebase Auth gives you access to all the Firebase SDK within Flutter to handle its authentication. And then Google Sign-In, and because this will actually provide you with all the necessary logic for Google Sign-In that comes with those nice windows that you get, and then actually exchanging the keys with Google, all that stuff is done through here. So we grab those, put those in our pubspec YAML, which is right here, Firebase Auth and Google Sign-In, and now we're ready to go. So first thing we've got to do is create an auth service, and just notice this shouldn't be here. Let me start over. That's from the test. Okay. All right. Okay. So let's create a folder for services, just like you saw before. And now we'll actually create an auth service.cart. So this auth service will handle all of the logic that is needed for not just communicating with Firebase authentication, but also with Google or Facebook or whoever you want for login, and even just traditional email and password. So for this to work, we'll do a Firebase auth. We'll create a Firebase auth. Just call this auth, and we need to import Firebase. It's already imported. So this will create an instance of the library from Firebase that we need. And let me close this so it's easier for you to see. Oh, okay. I just noticed I wasn't showing my code. Sorry about that, guys, but we just started, so should be good. Let me just make sure that's okay. Okay, all right. Yep. All right, so where was I? So we're creating a Firebase Auth instance, and now we'll create a Google sign in and call it Google sign in. Okay, so this will be responsible for all the logic regarding to Google. And now we can actually start developing our methods. So we're going to create our first methods, and this one will be to actually do the exchanges with Google that are necessary, and then providing a credential into Firebase to actually perform a login. So the way we do this is we do void, Google sign, or actually I prefer to call it sign in with Google. There we go. So this method is going to have 3 steps. First step is we go to Google and initiate and request the windows and the logic to actually perform a login. Then when we get that login, we exchange that for a credential, and the first step is providing that credential to Firebase. So for the first step, I'm going to create a Google user and await Google sign in dot sign in, I believe. Yep. Okay, and since this is asynchronous, the function needs to be asynchronous as well. Next, we're going to create a Google auth, and this is going to fetch from the user the actual authentication. Okay, so this is just for readability. I prefer to do it in separate lines. So next, we'll do actually getting the credentials. So in order to get the credential, we do Google auth provider. I think okay, yep. So get credential, and let me just put this in a way that it's more readable. So in order to get a credential from Google, you need both an ID token and an access token. So you get those from the authentication that you just performed. So here we have the ID token, and here we have the access token. And missing a comma. All right. Okay, so this provides us with a credential, and this is of type. This is of type of credential, and then this is exactly the type that then you send to Firebase. Now, normally, what you would do for the first step is you just do auth dot sign in with credential. So now you're telling Firebase that you want to sign in with a credential that was generated somewhere else, and you just provide it, and that's it. You get a Firebase login just with this. But for future's sake, I would say that normally you will put more methods of signing in here, including a login with username and password, could be a login with Facebook. So you want to probably export this out into an actual method just of its own, and that would be a sign-in method, okay? And this receives an auth credential, of type credential. One sec, and then it just returns auth dot sign in credential, which in turn returns you so sign in that's it. So this returns the sign in, but now you actually want the user that comes with that. So let me what am I missing here? Let me just check my notes. Sorry about that. No, that's right. Okay. No, I was right. So that's all we want to return. Sorry. So we first need to perform that, and in an asynchronous fashion. And then we actually can return the user from that result. That's why it wasn't popping up. Okay? So that user, that's of type Firebase user. Firebase user is the combination of all of this. It is a user that has all your identities that Firebase also holds on you. And this already comes pre-packed with some interesting information, especially with the Google login. You already have, depending on obviously your settings with Google, you should already have an email available here. You should already have a photo URL, and even your display name. In some cases, even your phone number, but I advise against that. So now we have to, again, since this is asynchronous, we need to provide a feature of Firebase user. Okay, so now we have that here, and instead of running this, we just do this, and again, we need to return that Firebase user. Okay, so we've done all the code we need to perform a login. Now we just need to put it in our app. I'm gonna start running the app in the meantime because it was actually not connected to the emulator. So now we're gonna open our login screen, okay? And here, where we have on-pressed login, we'll just write off service. We're gonna import the off service. Give it a sec, because now it's gonna get really slow for a while. And then we do sign in with Google. Okay, so this is and we need to await this, of course. Otherwise, it won't wait for it. It will literally just go into the intro page, and it won't care if you actually performed a successful login. Okay, give me one sec just to prepare this. Okay, so this should be good to go now. Let's test it out. So let's actually go into that screen, and now we're gonna click login, and there we go. We have a login with Google. Now we're gonna click that login, and then it's going to go into the intro page. If by any reason that login failed, or if you just dismissed it, it would not go into the intro page. So that will only happen in the case of success right now. So now, how do you actually sign out? Because if you notice, if I just click log out and go to the screen, I'm not actually logged out. So when I click login again, it's not going to request me for the window. It's just going to log in because it knows I'm logged in. So we can create a quick sign out method. And the way we do this is we just write, sign out. This will also be asynchronous. And you just sign out of both instances. So you go to off and you sign out of it. So this signs you out of Firebase. And you go to Google, sign in, and you also sign out of it. Okay, where is it? There we go. Boom. Okay, and now just like with last time, we go to our home page, which is where our logout button is right now. It's here, right here. And we find it right here, and we say, okay, off service, and please import it first. Okay, please sign out. So now when you actually sign out, it will sign you out, and then when you log in, it will request for your login information again. Okay. So now let's do something a bit more interesting. We want to display. I've already even make like some placeholders here. We have this username and user email, but they're obviously hard-coded right now. There's nothing to show, but let's actually show something. So here's what we want to do. We want to provide all of the app with the Firebase user that we just obtained. And the way we do this is with our in this case provider, which is again another package. So let me just show you real quick. So today I'm trying to not dwell too much into architectures like talks around forms or talks around routing or business logic. So provider is one of many ways to provide information to your app in Flutter. So this is the one we'll be using today. So I've already placed this in our pubspec YAML right here, okay? And what this allows us is to provide any child of that provider will have the information that you are providing, and let's actually show how that works. So if we go to app.start, this is the top layer of our app currently. Everything you see is under this. So what you can do is you put a stream provider here, and it is a stream provider. You'll see why in a minute, but basically we're going to be providing a stream of Firebase user constantly, and anytime that user changes, we're going to provide it down again. So the way this works is you say stream provider.value, and then you give it a value, which we're going to define in a minute. I need to import this. Okay. So right now it's providing null to all of my app. Obviously, that's not interesting at all. So let's see how we can actually provide good information. So you can get a method that provides a stream of Firebase user super easily, because that's already incorporated in the instance. So let's put here Firebase user get user, and we just return. I believe it's off dot on off stain, on off changed. There we go. So as you can see, this method provides you with a stream of Firebase user, which will now, for anyone subscribing to it, it will be provided there. But here's the thing: I could already go here and say off service, and in fact I will actually, off service dot get user. Okay, this is working, but I usually prefer to keep the Firebase user within the off service, so I think that's a better practice. So what we're going to do is we actually have a user model here, okay, and this user model, I prefer to actually pass this user model along the app instead of having to convert it constantly, right? So what we're going to do is anytime we get something here, we're going to convert it to a user first and then give it into the stream. So the way we do that is we create a method called user convert user, okay, and let me just make sure I'm not forgetting anything here. Okay, yep, okay, and this user takes in a Firebase user, and oh, and I need to import the model as well. Okay, so this method, what it'll do is, if as long as the user is different than null, it will return a user, otherwise it returns nothing. But now regarding the user that it does return, let's actually populate it. So we're going to say that user's UID is this user's UID, because that's how it is on a Firebase. That user's name is user.displayName, because again, all this information already comes in your Firebase user, so we're just passing it through a model to make it more convenient to our other classes. So I think the next one is email, user.email, and finally avatar user.photo URL, right? Yep. Okay. So we have a method that converts a Firebase user into a user. Now let's just quickly map it here. So what you do is you just map it, and you just do for each user, convert that user, please, and just change here to user, and that's all done. Notice that I prefer to put this in more clean way for those who, this is just like a small advanced tip, but this is the same as this, okay? I just think it's cleaner, but I'll leave it in just to have everyone understand. Okay, so now here we actually are providing all of the app with a user. We can even say so right here. And how do we actually access that? So again, let's go to the home page. So the home page is this page right here, and let's find where we're saying, okay, right here, username and user email. So just before we start generating our views, let's grab the user from the provider, okay? So the way you do that, and again, we need to do some imports. You do provider.auth and context. But it's best practice, and ideally, you tell it what type it is of. So that's how you do it. Okay. So this already, so now anytime you log in or log out, all of your user information is going down the stream, and it's going to any view that is requesting it. So this will always have the most current user. So now we're gonna go here, just gonna display user.name. And in case you log out and you have nothing, just display nothing. And here we can put user.email, and again, just put it with nothing. Now let's save it. There we go. See? So now we have my name and my email on the screen, and this is being literally fetched from my login information. Let's make one even better. So last week our friend Vaneto's placed this user icon here. So I don't like it because I'm going to take it out. And instead of it, we're going to put my photo from my actual Gmail. So the way you do it is you do image.network. This allows you to to actually fetch an image through a URL, and then we just do user.avatar. So this won't be pretty, but it's going to work, right? Ideally. Okay, there we go. So that's my user image. I can just make it a bit prettier. Nope. Okay. So I prefer click oval, and let's add some padding to it as well. Actually, there's a quicker way to do that. Right here. There we go. Much better. Okay. So I taught you how to create login logic, access your login data, and sign out. There's one last thing though, which is that this isn't necessarily protected or well implemented. And the reason is, right now, if you, right now, for example, I'm logged out, but if you notice, the initial route of my app is always route intro. So that means even if I'm logged out, so even if I'm logged out, if I close the app completely, it's gonna always open up on this window, even if I'm logged out. So that totally defeats the purpose of the login functionality. So the way you do this is you usually set your initial route to something that performs a check for that user that again is being provided, and then you return which route you should go to based on the response. So let's just do that real quickly. And sorry, so route alf, we'll replace it here, and we're going to create a route. Well, I can define it here already, but I don't have the page created yet, but I'm going to create it in a minute. So this will be off page. Okay, so off page, you can just put it down here to be easier to access. So off page will be a stateless widget. Again, it's just performing a simple check, and what we'll do is, just like we did on the home page, we're going to fetch that user through the provider. So final user equals provider.auth user context. Okay, and now just simply, if the user is different from null, again, this is a very rudimentary version that you can be much more complex with this if you want. You return the intro page. So this is basically, if you're logged in and the user exists, go to intro page. But if you're logged out and the user does not exist, do not go into intro page, go to login page. Okay? And that's it. I'll be able to show you this one in a minute. I need to kind of rerun it because just for emulator reasons, but this essentially now, anytime you open the app, it's going to first go to this route, then it's going to check if you are logged in or not, and then it's going to send you to the correct page based on that. Okay? All right, so now let's go, before we go into the next section, sorry, I'm looking for the keynotes. There we go. Okay, so now the next section we're gonna talk about database. and because the point of today is to show you a bit more of how to put your app with real data, real live data, and real live functionality through Flutter. So we've already done so with login. That's real, that's live information. But it's going to get even better with database. So Firebase provides you with two databases. These are the Firestore and the real-time database. Essentially, the Firestore is just a shiny new one. The database was the older one. You almost can't go wrong if either. They're both NoSQL document-based databases, and if you have, like usually I just go with Firestore. If you have any doubts about which one you should go with, not only will you find many articles about this, but also in the Firebase documentation you have a section where you can actually basically click on what your needs are, and based on that it will tell you which one it thinks is better for you. Okay, so like I was saying, both of these are NoSQL, and they much with like any NoSQL like MongoDB, etc. They're schemaless, and they have barely any restrictions to what you can put in them, right? This is also not news to mostly anyone, but usually to mitigate this, what you do is instead of just having information going from your app to the database and forth like constantly, you're just running through a model, right? So that's what we're going to do today. When we put information on the database of a recipe, actually we're not going to be putting that today, but when we fetch a recipe from the database, we always run it through a recipe model, and thus we make sure that we always get the right information. Otherwise it throws an error and we do nothing with it. But this basically protects against one of the lesser points of NoSQL. Let's see that in action. Let me just change to coding. Okay, so actually before we go to coding, go to here, and much with the other ones, we do need a package. This package will be the Firestore one, and you just put it on your pubspec YAML and you'll be ready to go. And also I just want to show you the Firebase dashboard. I've already took the liberty of setting up a database, and it has some recipes here that already have all this information on them. Okay, so our goal right now is going to be to actually fetch the recipes from this database instead of fetching them locally and then presenting them. So let's go into code. Okay, so let me stop running that for a minute. Okay, so the first step is to create a Firebase service. Give me a sec here. First step is to create a Firestore service that is going to handle all the logic. So this is very similar to what we did before with the Alf service. So Firestore service.dart. So create Firestore service. Okay. So this is going to have so this is going to much like with last time, it's going to instantiate the Firestore. Then it's going to have the methods to actually deal with it, from getting collections, updating collections, all that kind of stuff. You can do it directly from here. So let's start by doing Firestore. It's not asking for the import yet. Firestore equals firestore.instance. And oops. There we go. Okay, so next what we're going to do is we're going to create a method to get a collection, and we're going to be using that method to get our recipe collection in a bit. Okay, so we're going to create get collection. It's going to receive the collection name, and it's going to be async because we need to wait for that response. So what this method does is I'm going to return await Firestore dot collection. So this fetches the collection reference, and you need to tell what collection that is. That's why you provide it in the method. And then for that collection, we want to get all the documents. And this provides us with a query snapshot. So the query snapshot basically holds all of the info for what we just queried, and now we're actually able to map it and run through that to actually, sorry, not map it, to resolve it into something. So I'm going to resolve it into query. I wish this would throw a new line though. It'd be much easier to read. Let me try to force that myself. I don't know if this is gonna work. Okay, I think it is. I think that's easier for anyone to read. Sorry. Okay, so for each query, we want to return query.documents. So this returns all of the documents that I fetched. So it returns all of those recipes that I showed you previously in the form of a list of document snapshot. And a document snapshot is basically a reference, or it holds everything that came from a certain document, from its ID and obviously the data. So we're gonna store that. Actually, we're gonna say that that's what we return. A list of document snapshot. But naturally, since this is synchronous, we need to feature that. Okay. So that's it. We have a method to fetch a collection. That's all we needed there. So next, we're gonna go to our recipe repository, I believe. Okay. So remember, I might have to start running the app soon. Okay. So, but I just want to show you first. So this is this data here. That is like these recipes are being fetched from this recipe repository, and if you notice, they're all here in a local fashion. So they're all hard-coded, basically pre-made. We don't want these, right? So that's right here. So we don't want that. We want to return them from the Firebase store. And it's actually interesting that the previous talk, Argel actually did something very similar, where he basically made this function into a future function and then actually created a future builder. So we're going to be doing that, except here the future is coming from the Firestore. So let's do that. So the way we access it is we call the service. And if you've noticed, we've been calling this Firestore service, the off service, all that stuff, always, all the time. Ideally, you would have a better system in place for like having dependency injection, for example, which allows you to not constantly instantiate this, but this will do for today. So we want to do Firestore service.get collection, and we want to get the recipe collection. So we know which one we're going to get. And we're going to get a list of document snapshots. Okay. I think I gotta wait this, and gotta make this asynchronous, and I gotta import document snapshots, and I gotta say now that this will be a future. Okay, no more errors. Okay, so right now we've fetched all of the document snapshots, but the app doesn't know what to do with the snapshots. So this is a layer where I usually prefer to convert those snapshots into recipes. So this is very similar with how earlier we converted the Firebase user into an actual user. So what we're gonna do is we're gonna go through those snapshots and map them, and for each snapshot we're gonna return a recipe. Okay. Alright. Now, this is the not so fun part. We have to actually write all of this stuff. So the ID of the recipe actually comes from the document ID. It does not come from the data, because I didn't place it in the data. That's also, so again, going on the web, if you notice, I didn't put the ID here. The ID is right here. Okay. That's why we are fetching it separately in document ID for that snapshot. So there we go. For everything else, we're gonna manually do snapshot.data. Then we actually have to put the entry that we want. So in this case, it's the named one. Sorry. And it will be like that for a while. So let me see if I can do this with no mistakes. So pieces, calories, and then we've actually been hard coding the duration, so that's fine. Again, this is just a quick test. So we've got asset name, which gives you the photo, start count, and review count. Okay. So don't forget to convert this into a list and store that list, which is now a list of recipes. And in the end, we can just return that list. Okay. So this is all fine, but now our app is actually having an error on the home page. And the reason, much like with last time with Argel, is because this function wasn't returning a feature before, and now it is. And this is not well built for features. So what I'm going to do is I'm going to comment this out. Sorry, that's actually wrong. I think that's better. Okay. And let me take this chance to start running the app because this is going to take a bit. And now let's pray that it doesn't break or anything. Let me take it out. Okay. So while it's doing that, we can write our code. So in order to provide a feature for our widgets, we need to use a feature builder. Let me just quickly change. So a feature builder provides you with an initial data before you have your feature. Then it actually loads the data once that feature settles in, right? So let's put that in. Nice comma. Okay. So our initial data, this is pretty standard. Usually it's just nothing. So just an empty array. Our feature, that's the actual function, right? So we're going to access our recipe repository that was fed into this page. And we're going to say get special recipes. And now we actually, sorry, I'm just having a few issues here. Okay, all good. All good here. All good. Okay. All right, so where was I? Now I need to actually build. So we do the, sorry, this is not index, it's snapshot. So this is the snapshot of what we're building. And now we need to actually return something. I would just return, I want to prefer a wrap instead of doing like the grid, just a bit easier for me. And a wrap has a set of children. So we're gonna now generate a list for that wrap, okay? And the list comes from what we get on the snapshot. So list generate is fairly simple. Let me actually see if I can get, there we go. Okay, so list generate just basically receives a length that you want to generate from, and then an index that for each view. Okay, so what we're saying is, okay, here is our list of recipes, and now for each recipe, give me a recipe. Okay, and obviously we need to tell that recipe, sorry, a recipe image, which, because it's a widget. Okay, so for each recipe, give me the corresponding recipe image. And if we look down here, recipe image receives a recipe, and recipe is inside the snapshot in this current index. And then it has an onClicked, which will remain unchanged. So I can even copy it from here, paste it here, and no. Ugh. Okay, might as well not risk it. I'll just quickly write it. Gate to detail context recipe. Okay. So what we've done so far is provide with the list, and if you notice, now it's actually working. It's obviously not too good. We'll make it good in a second. But this list is already coming from the database, this data. And we can even experiment with changing it soon, and we'll see that it's all there. But let's put this properly like it was before. So let's give it the hero. And we need the hero tag. Whoops. No. Okay. So the hero tag is the recipe itself. So again, that is snapshot data index. Okay, and I want to put this in a container, I think, just to make it better. So container, make it a bit smaller. All right, and now because this is a nice wrap, we can even do some spacing and run spacing. All right, so we've already showed you now how to actually access your database for some data and provide it. Right here, vegan supreme pizza. This is coming. Let's actually experiment changing it. So going to the web, and let's go to the okay, let's do the omelet sticks, and let's say it has 1,000 calories. Yeah, no, that's a lot. Okay, so now and notice there is one fault here, which is we didn't do a pull for refresh. There's no place where this is refreshed. This is only called when this view is called, and right now the only way to force this view to be called again is actually logging out and logging in again. So we're just going to do that. Now it's actually fetched again. So the sticks, I believe, are these. There we go, 1,000 calories. Okay. All right. So back to coding. So now I think we still have a little time. We can. Okay, we'll do the opposite way. So let's actually change the database data with what we are having here. So last week, our friend Jean did this button here, but it's not doing anything. Well, let's actually make it favorite in the database. So if you look at the database, currently we have isFavorite as a parameter for that. And let's go to code again. So what are we going to do for this part is we're going to write a method to like a recipe, okay? And then we also write the method to update that recipe on the Firestore. So let's first go for the Firestore method. And this one is going to be pretty simple. It's going to be update document. And there's many ways you can do this, but essentially this way we would just be doing what we would just provide the string collection and the ID of the document you want to change, and then the actual data that you want to send to it, okay? And it will only change that data specifically. Like if I only tell it to change the isFavorite, that's the only thing that's going to change. It's not going to replace anything else. So what we're going to do is just await Firestore. Pretty simple. Collection, document, ID. So this references that document specifically. And now you have access to CRUD operations for that document. So you can delete it, you can actually fetch it, set it, update it, whatever. So we're gonna update it and provide it with the data, and that's it. That's how you update a document. Let's test that in a minute. First, we gotta do the like recipe method on our recipe repository. Okay, so our like recipe will just be basically a method that receives a recipe and is going to insert it with within our database. So like recipe, we give it a recipe, and we give it a boolean of if we like it, if we like it or not, and then we just call Firestore service dot. Give it a sec. Okay. Update documents recipe recipe.id, and the data is going to be, okay, give me a sec. The data is going to be is we gotta string it is favorites. That's it. That's all you need. Well, that and actually putting it on the on click of that button. So that's what we're gonna do next. So we're just gonna go to the detail page. This detail page is this one specifically that you're seeing right now. I'm going to just search for favorites. Okay. So this is where the favorite, that little button with the heart, is initialized, and I need to pass the recipe down to it so that then the button is able to tell the repository that it wants to like or favorite this recipe. So I'm gonna do that real quick. We're gonna put it here because we have it in a widget. I believe it's widget.recipe. And here, if you notice, favorite is created right here. We're just gonna make a constructor for it. So first we declare recipe, and then we do favorite this.recipe. Okay, so that removes all errors. Oh, I don't need widget here. There we go. So now we're passing the recipe inside the button, so the button knows what recipe it is referring to. So next, all we need to do is when in the logic, and again, this was all explained in last week's talk. This is from João's code, so I changed nothing here. This on tap is where it is switching and animating the button. Now let's also make it call the repository. So we just do recipe repository. I think we need to, I don't know if we need to import it. No, okay. Dot. Wait, I think I got the wrong name. It's 2 E's, exactly. Always make it just 1 E. So, and now I actually need to import it. There we go. So recipe repository, like recipe, and then we just give it widget.recipe, because now we have access to the recipe. And we say, what are we doing? Are we liking it or disliking it, which is held in this variable. Okay, I think that should do it. Let me just make sure I refresh it. Okay, now let's try it. Moment of truth. Okay, so let's go to the omelet sticks and like it. There we go, it refreshed on the database, and now we dislike it. False. Okay, and same for the chicken taco. Chicken taco, gonna like it. True, false. It's really fast, isn't it? So yeah, let me like it again. Okay, I like that. Okay, that pretty much sums it up as far as what I wanted to do with coding here. And let me just go back to the keynotes. So just to close up, I just wanted to talk about a few more things, namely Cloud Functions. So Cloud Functions is also a great tool for Firebase, and because basically they are serverless frameworks that allows you to run backend code in response to events or be triggered by Firebase or by an HTTPS request. So you store the code in the cloud, and then it just manages everything for you. It will manage when to keep it alive, when to wake it up, which in turn makes it much more cost effective, both for Google and yourself if you are paying for it. And it also scales it no matter how many, how big your needs. Google can handle it, right? So for the purpose of this presentation, I was hoping to do a quick demo of a function. I will show it, but I won't be live coding it. So essentially, this is one of many uses of Firebase functions, and I can talk more about it in the questions area. But essentially, one of the uses I usually do on all of my apps is whenever you trigger that login with Firebase authentication, there's a create user that is triggered, right? In fact, I did not show you, but if we go here to authentication, see how there's this user? Let me actually delete that user. Okay, give me a sec. Right, so there's no users here. When I log in for the first time, so in this case it would have been a sign up, right? A user was just created. See? So now it shows up. Okay. So when the user is created, I usually deploy a Firebase function that grabs that, gets triggered with that user creation, and then grabs that user information. Then after grabbing that user information, it stores it in the database, thus creating an entry for that user. And it even does so in a way that where you store it, ideally, one way I'd like to do it is you store it with the unique ID as the actual database identifier, because one of the advantages of these NoSQL databases is you can mess with the IDs yourself, so you can actually use the UID, which is unique after all, as your ID, and then just put the email in. So this instantly gives your Flutter app an easy way to talk to the database, because basically your Flutter app says, hey, I'm logging in this user, I know his UID and email, I know nothing else about him. But if I know that his UID is the same in the database and that it definitely exists there if he logged in here, now I'm free to write code for example, get that user's information from the database based on his UID. Like, that's the matcher that I need. So this is a very big favorite of mine. And although I don't have the time to show you how to do this one, I do have a way to quickly let me just switch branches. Okay, one sec. Okay, hopefully that works. There we go. All right. Okay. Go to coding. Okay, so with Firebase functions, usually what you do is you have to have Firebase SDK enabled on your Mac or PC. This is all set up again. If you just go to their functions section, which is right here, and you already see the one I was talking about here in a minute. If you go here, when you go to it for the first time, it's going to tell you how to do it. Okay, how to do the Firebase init, the setup, and then the deploy. So once you do the Firebase init, it's going to create all of these. One sec. It's going to create these files right here. So you're going to have package.json, the build information, and the base index. And then you can write whatever code is needed for that function and deploy it. In this case, this is all the code I needed for that function that I just talked about earlier. So if you notice, what I'm doing is just doing fetching the information that I need from the node modules. This is JavaScript, and then you just do create account. That's gonna be basically the name of the function. So this is how you separate it out. Like, I could actually have a second function right here if I placed it like this or something. Right now I only have one. So this is how it compartmentalizes. Whatever is inside here is compartmentalized. So here I'm just saying, okay, whenever a user is created, right? And again, the advantage of the cloud functions is that they're directly connected with all of the Firebase suite, so it's able to do this very easily. So whenever a user is created, grab that user and go to the Firestore and basically set, or in this case create, it inside it. And notice that I'm saying do that with the UID of this user. So right now I'm placing, anytime I log in for the first time with a user and thus create it, it is going to be placed in the database with email. And if you look at the web and you go to database, you can already see that I already have that here, right? Okay, that pretty much concludes the talk. I wanted to talk about, I will be going to questions now. I just want to say again, so we only covered a really small part of all of the Firebase capabilities today. There's many that you can use. Usually I use this first suite of build your app with authentication and database mainly, and functions. These are the free trifecta, basically, as I call it. But there's many other things from machine learning and analytics, which then ties into A/B testing and distribution, and you can do notifications and messaging through the Firebase. You can find easily all sorts of tutorials, articles on all of this. And I didn't even cover storage, but again, it is super easy to use storage. In fact, I was going to use it for this, but we didn't have enough time. So essentially, you just drag and drop your things into it, or you can create folders, and then it generates URLs that are managed, and you can even protect it through rules. So yeah, that's about it. I'll go into questions now. Give me just a sec. Mm-hmm. Okay. Mm-hmm. Okay. So just to clarify, guys, I'm getting the informations fed through Venetos. Sorry, Venetos, can you repeat the question? Just because I was thinking of. Yes, you can connect Firebase real-time with Cloud Function very similarly to what we just saw with. Oh, sorry. The question is if I can connect Firebase functions, and the answer is you can connect that very easily, and it will be almost not different at all from what I just showed you with the Firestore. Okay, so they will function very similarly. Any more questions? Okay, so the next question is, when should we use a custom backend versus Firebase? That's a very good question. I myself have had this question about around many projects. There are many cases where I did so. So my first answer is Firebase does not immediately exclude you from doing a backend, because backends have many different purposes, right? For example, I've done a backend just for I've done a backend before where I actually had that the authentication logic, the Google exchange of tokens, all of that written with the OAuth protocol, etc. And now with Firebase, I don't need that, but I can still get that from Firebase and then have a backend for example, a REST API, etc. separately, right? So the first part of me answering that is saying one does not exclude the other, right? But nextly, I would say you should have a backend for anything that's heavy that you don't think makes sense being separated out through the functions, but you'll be surprised of how much you can put in functions. That basically makes you not needing a backend, because most of the time with a backend, you're accessing it through requests, and the functions can handle any requests you want. And pretty much what a lot of people do is put actual servers on those functions. I've even experimented with putting a GraphQL Apollo server in a function, and it does all of my GraphQL requests just through that, and I don't need a backend. Firebase is doing that for me. So again, doesn't exclude it, but it always depends on your needs, and only do a backend if you find that Firebase does not fit those needs, which to my experience mostly it has, but it's definitely a case-by-case scenario. Okay, so the next question is, what limitations have I had with Firebase? And if I think the last part was if I wanted to use some other solution, right? Or which one I used, I suppose. Okay, so yeah, definitely one of the limitations I found recently with my team at work was actually with the Firestore. But it's not a huge limitation. It's just that our project was definitely pretty big as far as data exchanges, okay? And one issue that I find that is not even specific to the Firestore, this is more of a NoSQL issue, is with relating database entries, right? So for example, if I, let's talk in the terms of what we just saw with the recipe. So if I had a recipe and I wanted to then get, I had reviews, right? What if I wanted to get all of the reviewers from that recipe? Typically, and even this is actually what Firebase will tell you in their documentation and videos, you would actually pre-place some information of that users inside the recipe document, which usually is a bit weird, right? You say, why do I want user information inside my recipe? Well, this is because then when you fetch the recipe, you already have all the information. Otherwise, you're going to say, okay, I got the recipe, and it has a list of user IDs, And now for each ID, I need to fetch a user, and that's a lot of fetches, right? So that's a limitation that I ran into. So the solution, one solution that's pretty easy for this is actually what I was mentioning before. This is why I did it. I placed a GraphQL server inside my functions. And so for those who don't know what GraphQL is, it is a querying language that is much more powerful and complex than traditional requests that you would do. And it is very easy if you set it up nicely, and there's videos to, like, you can do this in super quick, like in less than an hour. Set it up nicely on the function and connect it to your database through the Firestore SDK. Then suddenly in your Flutter app, you're no longer accessing the Firestore SDK. You're just making HTTPS requests, or in this case queries, to GraphQL. So then I can say, hey GraphQL, give me this recipe, but also give me the users of that reviewed this recipe. And because GraphQL is relational, it is able to do that in one simple request, thus mitigating the Firestore issue. Okay, so essentially, short answer is yes, I found some issues, just because Firestore as an NoSQL database did not fit my needs, but I was able to mitigate it with GraphQL on top of it. And I haven't found issues with anything else so far, at least. Any more questions? Okay. Mm-hmm. Okay. Oh, okay. Oh, sorry. But so should I end the stream or? Ah, okay. So I see. Oh, because of the. Okay. So basically, I'm gonna do the outro. This has been our Flutter Portugal live talks session 2, and it is now over. And they're having internet issues, so they want me to thank Argel and myself, of course, for all the time that we have provided for this. And they want to say that we'll have in the future more talks. And please follow Flutter Portugal on Twitter and on Discord. We all. Yes, and thank you for watching. We'll always be in the Discord chat. Please remember also that, and let me actually just provide it. Please remember also that all of the information for all of the data that you saw on this talk will be on my GitHub later this weekend. And that is all. All right, I'm gonna end the stream now, okay? Okay, bye everyone.